Welcome, this is lesson 1.3, notes. Our topic today is other sampling designs. The goal for these notes is, we have threefold. Follow the systematic sampling process, use the cluster sampling to obtain a sample, and implement stratified sampling with proportional allocation. So in this lesson we are acknowledging 3 additional sampling methods from yesterday's notes where we identified simple random sampling. Simple random sampling is great. However, we may need a more specific method to ensure a representative sample. Representative sample being practical regarding the location of our sample comes into play as well. Systematic random sampling is the first one we'll talk about, and each one of these has its own process. Why we would use this method: it's easier to execute than simple random sampling, and it typically provides comparable results. That's nice, a little easier. How to use this method? Step 1, we divide the population size by the sample size and round the result down to the nearest whole number. Now that's unusual. We round the result down. And we're going to call that result M, okay? The reason we'll round that down will become apparent as if we rounded to the nearest whole number like we typically do, we might go outside of the numbers of our actual population, and whereas we couldn't get the entire sample to fit within that range. So step 2, use a random number generator or table to obtain a number k between 1 and m. So k is also a variable that's coming into play, and that's going to be found but using this random number generator table, and it will be a number between 1 and m. Step 3, select for the sample those members of the population that are numbered. So we have k, k plus m, k plus 2m, and so on down the line until you reach your sample size, your desired sample size. Here's a little visual of that. So you have these segments broken up by this letter M. These groups are all size M, and then K would be the number, that random number within that range of 1 to M. Okay? Let's see how this works. Recall the example from class using our BTSOA student roster. The population size was 129 students with a sample size of 10. We're going to follow these steps in order to create a sample using systematic random sampling. So step 1, we divide the population size by the sample size, and then we round down to get our value for m. Step 2, that's where we find k, a random number between 1 and 12. And so I would use a random number generator. For the sake of time, I'm just going to randomly pick a number, is 5. And then the next step, we're just identifying each one of these members within that range of 1 to m, or 1 to 12. So the first one is k, right? It says here k. You follow these steps, you'll be good. The next one would be k plus 12. Or 5 plus 12, which is 17. And then we keep on adding 12, right? So you could follow that method and say, okay, now 5 plus 2 times 12, and 5 plus 3 times 12. What we're really doing here is just adding 12 each time, right? And so another way to do that is grab your calculator, use your mental math, and just take the previous number and add your M value. So then we go up to 29, and then add 12 again. We get 41. Look, remember, we're looking for 9 more, so 10 total. Our sample size is 10. So plus 12 again, right? We get 53. Nice to have one of these, just a simple scientific calculator handy to do problems like this. Add 12 again. You can even use your cell phone. 89, right? Add 12, we're at 101. 113. So you can see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. That's our sample. So within that BTSOA student roster, these are the students that we would select from that database. So that is systematic sampling. The next one we're talking about is cluster sampling. Cluster sampling. We would use this especially when the members of the population are widely scattered. So you can see you break this population into some subgroups. Sorry, I forgot to fill in this blank. Geographically. So step 1, divide the population into groups. We call those clusters for this method. Step 2, we obtain a simple random sample. So you see this simple random sampling finds its way into each of these, or several of these different sampling methods. Step 3, you use all of the members of the clusters obtained in step 2 as the sample. So notice we have here our 5 clusters, and within those clusters a random sampling method was chosen. So it's hard to see these numbers here, but this is cluster 1, cluster 2, cluster 3, cluster 4, cluster 5. And the random numbers chosen were 1, 4, and 5. So each of those clusters is entirely a part of the sample. No one from group 3, no one from group 2 is represented in our sample for cluster sampling. So here's an example. The city of Hamilton had to decide whether to invest millions of dollars into the new Spooky Nook Sports Complex. Now, I made this example up. There is a true Spooky Nook Sports Complex, and surveys were done, but this is totally a made-up example, but based on true to life. The city council sent out a survey to 20,000 residents. And as often occurs, the vast majority of responses were either strongly for or strongly against the city's investment in the complex. So that underrepresented the average Hamilton homeowner, which is really important to include in the survey. So one staff member decided to interview residents in order to offset the non-response bias. However, interviewing homes at random all over the city would average 20 hours of travel time. Right? We identified in the beginning this method is useful when the population might be scattered geographically. That's inconvenient, a lot of hours to pay that person to just be driving around, that city staff member. So that staff member recalled from her high school stats class the benefits of cluster sampling. She divided the city into 842 blocks, each containing 18 homes. So explain using the steps how the staff member used cluster sampling to obtain 200 homes. Notice we want 200 homes, that is our sample. Sample size. So step 1 is to divide the population into subgroups. Check, that was done. So that's the 842 blocks of 18 homes. Step 2 is to obtain a simple random sample of the clusters. So in order to obtain the simple random sample, we first need to divide, so 200, that's our sample size, by the number of homes that are in each block. And we then can calculate how many blocks we need to survey. And then we would use a random number generator, right? These blocks we would have numbered from 1 to 842. Randomly, we would select 11 of those blocks. And then step 3, use all of the members of clusters obtained in step 2 as the sample. So each one of those blocks, so if I use a random number generator, 842 different blocks, so I might select randomly, we use that random.org website, and it gives you just totally random numbers between the first and last number, not in any particular order. So these are the results of my random.org results. I said the results of the results. So these are just the results of my table within random.org. So 1, 2, 3, 4, 5. We need 6 more. So 279, 156, 811, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 817, and 302. Okay, so those would be the blocks. Like, go travel to these 11 blocks and sample every single home within each of those blocks. There are some drawbacks to cluster sampling. Okay, so you can see this picture over here. It's a little hard to see. The drawbacks, you can see this represents a different study where the city was determining whether or not to get a city pool. And there were upper and middle income housing, and you've got these clusters of homes, and you can see that these more affluent blocks, 65% of them own pools, versus the low-income housing, only 7% own pools. So 70% opposed using their tax dollars that had all these pools to go to a city pool, whereas in the low-income clusters, we have 95% want a city pool. So you can easily underrepresent certain communities because it is random and you're selecting whole blocks and whole clusters and sampling everyone within those clusters. But it has a lot of benefits as well, as we mentioned in the beginning. The next sampling method, the last one for today, is called stratified sampling. So stratified sampling, similar to cluster sampling, we break the population into subgroups, and in this time we call them strata, for stratified. And for each stratum, notice that's the singular, that's the plural, obtain a simple random sample of size proportional to the size of the stratum, right? So if you have a really large program like at School of the Arts, visual arts is really large, and the dance program's a little smaller, so this would say we need to sample more visual artists in order for that to be proportional than the dance program in order to be stratified, and with proportional allocation, which is what we're going to fill in here. And we use this method because it's more reliable than cluster sampling. The groups of strata are often sampled in proportion to their size, and that is called proportional allocation. And that gives a more representative sample. Remember from our notes, representative sample is key. Step 3, we use all the members obtained in step 2 as a sample. So here's the example. Consider again the town swimming pool situation. The town has 250 homeowners, so that would be the population, of which 25, 175, and 50 are upper, middle, and lower income, respectively. explain how we can obtain a sample of 20 homeowners, so there's our sample size, using stratified sampling with proportional allocation, stratifying by income group. So step 1. We're just dividing our population into groups. So that would be the upper, middle, and lower income. At School of the Arts, we might break our school up in the different majors would be our strata. Step 2, that's where we're actually obtaining those random sample sizes. So how many people, if we're going to want a sample of size 20, how many should we sample from the upper income group? We just make simple ratios, okay? So that's going to be part to whole. So 25 over the total, 250. And then we multiply that by the sample size. So I would say for step 2, it's super important to look at the example in order to kind of see how that fleshes out. So the result of that is 2. And then our middle income, the largest group here, is 175 over the total population, 250, times the sample size. And there we get 14. And you round normally here. Round as you normally do. Okay, it was just, that works out in this method. And then the last group, we have 50 in the lower income group. Part to whole times the sample size, and that gives us 4. So 4 homeowners from the lower income, 14 homeowners from the middle income, and 2 homeowners from the upper income. If you add those together, you get 20. So step 3 is use all the members obtained in step 2. So random sampling, we would select 2 homes out of the 25. Again, using that random number generator. So 2 homeowners randomly selected from the upper income, 14, I'm going to just use these quote marks to say repeat these words. 14 homeowners randomly selected from the middle income, and 4 homeowners randomly selected from the lower income houses. So I think just to conclude here, stratified random sampling and cluster sampling often get mixed up. So here's a little visual to come back to distinguish the difference. So you notice here we have different strata or groups. Here it's clusters. And within each stratum, singular, we are selecting members, okay, proportionally. And then that's not quite representative. This picture's a little off because we're selecting 2 here, but you get the idea. We're selecting some from each group. And then with cluster sampling, you're selecting some groups and sampling all. This concludes our notes. I know that was kind of a lot of information discussing 3 different sampling methods. Good thing about a video set of notes is you can kind of go back and rewatch. You can also do all the practice that I'll be providing for you to help it sink in.